2 plus I3. So this is just kind of idea. Can I change the color? Oh, okay, okay. So, but now it's a relative stiffness is also matter, since if this brace frame is relatively big, before we don't have this bracing, all the load is taken by this coil, right? So total I think win X, win Y, actually all taken by this coil. So now, since we have those brace frame, depends on the stiffness between the wall and the brace frame. So if this is getting thicker and stiffer and stiffer, this is taking more loads than the core wall. So those are the relative stiffness actually define how much load goes to the core wall, how much load goes to the each brace frame each end. So those are something that we need to consider. So let's go back to okay. Okay. So I try to explain to you. Oh, wait a minute. It's not the one. Okay, yeah. So I don't want to run entire model, so I just choose one core wall, right? I shape, concrete wall, and also I take the just one brace frame, right? And then this frame I just copy over here, and but only second frame I increase that area of steel on the column. I increase double. So instead of just choose the different members, I just using multiplier. For example, maybe step size of good features. Let me turn off that. So here, all this column, I choose entire column and assign, because this is more analysis stiffness I'm interested. So this is, I choose all the column, increase that cross-section area by 2. So I already assigned, so let me see. So you could see the property modifier here, area 2, right? So I tried to show you that we have a 3 race frame, but one on the left is just our original. Second one, I just copy and increase the column area by double. And third one, I just keep this column area, but I increase the brace frame bracing area also double. So this one is original. This second frame has column area is double. Third one has a bracing has a double steel area. So if we try to understand which element the effect more efficient to increase the overall stiffness. So those are all independent model. Okay, let me Control B. I'm gonna turn off the read. Right, I have all of this and try to make sure that I assign that you need same loads. Let me show you that on plan. I assign 500 kips in the Y direction at the top. So same load, I assign it and want to see that deflection. So let me just check deflections.
Professor, right? Where did you get the 500 kips from? I'm sorry.
No, those are random. I try to show you that effect. So 500 doesn't mean anything here.
Oh,
just okay. Some load. So if there's just same load, so it's on the plan, you can see this. So here, the deflection is 25 inches, right? But when we increase the steel column area double, the deflection went down to. How about the brace frame? Bracing, we double it, but the deflection is it went down 18. I think those are all the relative stiffness and geometry, but I think this combination of the column and brace frame bracing area increase will more optimal or efficient. But I think the column is more key. That is when you increase the column area, obviously moment of inertia formula I is AD square, right? So basically we are increasing area double, so that we can increase the overall truss stiffness. But this is so the concrete wall here we have a 14.4. So those are not just absolute. I'm not interested in absolute number, just relative deflection is the more interest. So this is just one kind of idea. When you this model, I didn't tie all. When we tie that what model is. What's the elevation? Okay. And elevation should be. Oh, okay, I made a mistake there. Oh. Okay, so this model, okay, supposed to be here, but anyway, just leave. So this model, full story, I add the bracing on each grid line A and G. So I'm gonna run and see that deflections. So I think what you have to do is once you add the bracing, now the brace frame on grid line A and G is gonna contribute, but we'll have to see how the building actually reflect, behave together. I think before all the core walls gonna contribute, right? So now we have brace frame each end. Let me see. When Y. And here 14.1 inches, 14.2, 14 inches. So why not symmetric? I think our one brace frame, I don't, somehow accidentally I drew it unsymmetrically. So maybe stiffness on brace frame on A and G is not identical. That's why maybe see the deflection 4.16, 4.07. But anyway, overall deflection and went down. Just only pure wall itself, we have deflection 20 inches, right? After we sized all the column and add the bracing, right? That overall building deflection is went down 14 point about 1, 2. So this is kind of procedure, or I think you could see, you can understand the contribution of brace frame is also helpful. In the lateral stiffness wise. And what also now we've been talking about deflection, but now just take a turn on the axial force diagram. Since this is a truss form, we are apply the wind load on in the positive y directions, right? When blowing this plan to the wind north, so we're gonna have some overturning moment, and then on windward side we have a tension force, leeward side we have a compression force, right? So that doesn't make sense. So I think you have to just to see that the member axial force diagram under the wind load. So wind blowing this direction to here, wind blowing positive y, right? So that on the windward side we have a tension of lift, the other side we have a compression side. So which is makes sense. Since we have a x racing, you see that the axial force compression and tension, which makes sense. Let's see what else. So I think now we are lucky that this geometry seems we can handle with this exterior 2 brace frame. So we could just add more some additional stiffness with the more reasonable wall thickness in the middle. And previously, without this brace frame, your core wall has to be taller, thicker, 36 inches and 14K side concrete. I think that is extremely rare and too expensive. Again, the wall thickness, increasing the wall thickness is not really efficient. You're adding a lot of material and increase the concrete strength instead of increase the overall moment of inertia. So practically a 40-story building, yeah, we haven't, we not just try to